Okay. Step 3.
TGIF.
Guys, there's 2 people testing. We need to be silent today. Also, some of you, I love you all, and I'm saying this on the video, need to lock in seriously. So we chose 15 dogs in the most horrible way on the table of random digits, if you remember. Now, I have a question, and be honest. Did the homework go into stuff that you didn't know yet? Okay, so pause on that. And I'm sorry, I should have modified it. We were so pressed for time that I didn't stop to look at the homework, but just pause on that for now. Okay, does this make sense that I labeled the dogs 001 to 118? You guys remember the dogs? Okay, that I did rand int 135.1 to get the line to start on. So this gave us line 26 to start on in our table. This is what took us all period. This is the 15. And by the way, some of you are scary good at that. Like scary good at table of random digits. I like couldn't even believe how good you were. Okay. And then so I want to make sure that you guys understand we don't average these numbers. These are the numbers of the 15 dogs that we chose. We get the weights of those 15 dogs and we average the weights of those 15 dogs. Do you know what I'm talking about? Are you sure? No, you don't. I just saw somebody say no. Okay. So the first dog is, well, not really the first dog, but one of the dogs we chose was dog 117. Dog 117 is a wire fox terrier who weighs 21 pounds. Does that make sense? Okay, so you would say dog 117 weighs 21 pounds. I don't want to do all this if we don't have to. If you guys can grasp what I'm saying beforehand and say, okay, I'm going to go to each of these dogs. What's the weight of dog 56? Dog 56 is an Irish water. What even in the heck is an Irish water spaniel? 50 pounds. So that would be 50. And you would get all of the 15 weights and you would add them together and divide by 15. Does that make sense? Are you sure? Okay. Okay, now set this up. And get excited that it says technology and not table of random digits. Did the homework have stratified random sampling and cluster sampling in it? Okay. After you're done writing this, find your blue pages. Does anybody need more time on the notebook? Are you sure? Okay. Tell me when you're done. Okay, before I move on, I want to tell you guys something really important. The table D, technology, and the hat method are all three separate things that don't have anything to do with simple random sample, stratified, and cluster. You can do a stratified random sample with table D, or with technology, or with the hat method. These are types of sampling, and then the methods are the hat, technology, and table D. Yes. Really, right now is a good time to ask me about going to fill up your water. Okay. Okay. All right. So now we're going to define stratified. So we did a simple random sample before. Simple random sample means that everybody's up for grabs. You can just take your sample completely randomly out of the entire population. This is a little bit different. This is called a stratified random sample. And it doesn't get a fun name like SRS because SRS is already taken. A sample chosen in which individuals are separated into stratum. Stratum are groups with like characteristics. A proportionally sized SRS is chosen. Now this is simple random sample is chosen from each strata. Nope. Strata is the singular, stratum is the plural, and what you do to it is stratified, and then combined into one large sample. Okay, so these are the steps. Step 1. Separate population into stratum, which is groups that have something alike. And number the strata. Okay, we're gonna do this step first on our dogs thing. If you guys can find the second list of dog stuff, it's dogs listed by size. Okay. Okay, so in this resource page, the dogs have been separated differently. They're not alphabetical this time. This time they're organized by strata. Okay, so here's the thought. The thought is, if you take, I don't know what's happening. If you take this, oh, I'm not mad. No, I was laughing at Darius. I think I know. Okay, so the thought is that when you take a simple random sample, what if there's a bunch of dogs, like small ones that get selected just by chance? What if you select like 10 of your 15 were teeny tiny dogs. It would throw off the sample. The idea here is if we do a stratified random sample, we'll make sure to get some of each size so it will balance it out. Because a simple random sample is just going to be like, randomly, let's choose these. What if we got all tiny ones? And then you're like, oh my gosh, all the dogs at the show are tiny. That's not actually true. It's just that that's the weird sample you ended up getting. This is a way to kind of control, to make sure that you get some out of each group. Okay. In this case, because the dogs are listed by size, these are the stratum. So we're going to number the stratum on our page here. So the large group, we're going to call that strata 1. The medium group, we're going to call that strata 2. Lots of mediums. And then the small group, we're going to call that strata 3. So we just did the first step. We organized. So I want you guys to picture, okay, you walk into a dog show. Pretend you see dogs in crates as far as the eye can see. Okay, on this first page, the one we did on Tuesday, all of the dog crates are listed alphabetically. Pretend that you could go up to each one and it was in alphabetical order. Okay, this time, imagine it's like Hogwarts and they all lift up and then they rearrange themselves and all the small ones are here, all the medium ones are here, and all the large ones are here. That's what we just did. We just separated them into small, medium, and large. Okay. Step 1. You guys imagine like Hogwarts? Okay. Calculate the proportion of each stratum to be sampled. What this does is it guarantees that you get something from each group. Simple random sample is great, but there's a chance that you might get all giant dogs or all small dogs. You're not sure because of randomness. This is going to guarantee that you're going to get some small, some medium, and some large. Okay, so that's its advantage. All right, so let's go back to here. Let's calculate our proportion. Okay, first thing we need to know is how many dogs are we looking for total? 15 dogs. Okay. We want 15 dogs. And how many dogs? So what's the range of dogs in the list that are large? What? 24? I think there's 1 through 24. Yeah. Is it 24? Okay. So large dogs are dogs 1 through 24. And what we're going to do is we're going to take the amount of dogs divided by the total. Which tells us that we want 20% of our sample to be large dogs. Okay, how big is our sample? $15. How do you do 20% of 15? Times. Okay, so we're going to select 3 dogs from our large group. Now, we're not going to do it with the table of random digits. Don't worry. Okay, now, how many medium dogs are there? So it goes from 25 to 79, I believe. If you subtract them, you get 54, but then you have to add one to count the 25th dog. So there's actually 55. Do you guys trust me that there's 55?
Yeah.
55 over 118 is 0.47. So you want 47% of our sample to be medium-sized dogs, and that comes out to be about 7. You always want to round to the whole number here because you've got to take out a full dog. We don't want to talk about half dogs. That would be sad. Okay. The last one is small dogs is 80 to 118. Yes, exactly. You could actually skip this step if you're Jake and not smart. Jake just said, oh, well, we already took out 10, so there has to be 5 more taken out. Okay. Any questions about how to calculate how many come out from each group? Do you guys see that it guarantees that you're going to get some large, some medium, and some small? Okay, so you see why that might be an advantage. Okay, so back to your blue thing. Next step. Choose separate SRS from each stratum. Okay, I'll pause here. It's really important that you know that when I say choose a separate SRS from each stratum, you could do the half method where you put like just the slips 1 through 24 in a half and swirl it around and choose 3 of the large dogs. Does that make sense? And you can put the slips 25 through 79, or the 25 through 79, the medium ones in there and pick out 7. You understand that? Or you could do the table of random digits method, which I don't suggest ever, if you can ever get around that. But we're going to use technology. Do you realize that all 3 of those are options for any of these? Okay. Just because we're doing technology for this one doesn't mean this one's always technology. I will always choose technology if I'm allowed to because it's the easiest. Okay, anyway, so what do I mean by that? I'm going to go here and I'm going to say, okay, I'm going to do a calculator command. Rand int, no repeat. Why am I going to choose no repeat here? Yeah, you don't want to choose the same dog twice. And I'm going to tell the calculator I want the lowest possible number of dogs that I could pick to be 1. The highest number of dog that I could pick would be 24. And I want 3 dogs. Okay, we got it. Is that better now? Okay, so this one, what would it be for the calculator command? Yep. So lowest number you would want it to choose is 25. Highest number would be 79, and you want 7 dogs. Okay, now we need to pause and seed our calculators, correct? Okay, if you have a brand new calculator. Okay, do you guys know what you need me to explain what the word seed is?
Yeah.
Okay, so you guys know like the table of random digits, you have that paper. And there's one in the back of your book called Table D. Did you look at it in fear when you tried to do the homework and you couldn't because I didn't cover everything? Okay, that basic same thing lives in your calculator. They put the same one in everyone. To seed a calculator is the randomly telling it what line to start at. We need to all start at different lines so that we don't all get the same table produced every time. Okay, so this is what you're going to do. Clear your home screen by pressing clear. So press the clear button. Enter a non-zero random value. Put your student ID in there, literally your 5-digit student ID. I'm gonna put our zip code. Okay. Then press the stove button. The stove button is right above the on button. It's for store. Stove. Then press map. Press the left arrow to select probability. Mine says prob, not PRB. Okay. Select one to select command and press enter. And it'll just spit your student ID back out if you go to your zip code or whatever. Okay, so now what we need to do is we all need to try this. Let's all try this and hope that we get different answers now. Hope we do. We want different answers to make sure that our calculators are working properly. Okay, so you're going to go math. What's wrong? Oh, Elena has a question. It's so quiet. If you think that's fun, my math retests today were numbered 7, 5, 3, 4, 5, 6. Anyway, okay, so we're going to probability. Rand int no repeat. 1, 24, 3. And if we did this right, we should all get different stuff. Ah. Do you need help, Cece? Yay. Okay. Okay, so these are my 3 large dogs that I would have chosen for my sample. Does that make sense?
Yeah.
Okay. Ours should be different. That's what sampling variability is. It means that you get different ones in every different sample. And I don't want us all to have the same ones. I do when I'm demonstrating something, but not like if you're actually doing a problem. You don't want to get the same thing as everybody else. So it's supposed to be random. Okay, anyway. Yes. I'm gonna have to be really careful in my grading. Uh-huh. Yeah, it might not do it the same exact night that time. I had to do them all last night though, because I had math retest today, and there's 90 of those. I did not put them in. There's 90 of those for me to grade. So I just kind of felt like that was going to be overwhelming. Anyway, okay, somebody willing to tell me what they think the command is for these small dogs? Raise hand. Raise hand. Anyone? Yes, Jamie.
Random int no repeat. 80, 118, odd.
Beautiful. Okay. Go ahead and get your yes. I want you to put, it doesn't actually matter. Okay. I'm not going to do the math, honestly. What I mean by that is I'm not going to figure out the weights of these 3 and do the weights of these 7 and do the weights of those 5. Anyway, 25, 79, 7. Does it make sense? There's 7 numbers. So you've got 3 of these dogs, 3 large, 7 mediums. Okay. Now, what will I do with, I got all these numbers, what am I gonna do with them? So I'm not gonna average these numbers.
It's the weight.
Yeah, okay, you're gonna get the weights. Okay, so it's really important. Last step is you have to take all of these dogs and put them together into your sample. All 15 dogs are your sample. It's not 3 separate samples. So now you combine it all into one big sample. You would find all of the 15 weights, add them together and divide by 15. We're not gonna do all that. Okay, but we are gonna go back to our blue page and we're gonna write combine combine all chosen individuals into one large sample. And it's not always going to be an average. Sometimes you're just going to ask them a survey question. Sometimes you're going to calculate a proportion. Sometimes it would be products coming off the assembly line and you would check something, measure something, weigh something, check to make sure the headlights worked. I don't know if I told you guys, I got to go to the plant where they make Ford F-150s this summer and watch them on the assembly line. It was the coolest thing ever. The moonroof part was the best part. I don't know if you've ever watched somebody take a headliner out of a car. Have you ever been part of, do you know what a headliner is? It's like all that soft part on the roof of the car. Getting that out of a car when the windshield is installed is really difficult. You gotta like bring it out the door. But these guys have it on a tray and they like, this robot would come in and like slide the headliner in and like boop and put it up through where the windshield hole is. It was like, I could have stayed there all day. Anyway, sorry. Car people, my house, car people. Any questions about stratified? So break them into groups that have something in common, proportionally choose, and then combine back into one big sample. Okay, now we're gonna do what's called cluster sampling. And I really need to make sure you guys understand the difference between a cluster and a stratum. A sample chosen in which individuals are separated into clusters. Groups typically conveniently located next to each other. An SRS is chosen of clusters. And all individuals in the chosen cluster are included in the sample. Okay, there are 2 examples of cluster samples that are my favorite. One of them would be like, let's say that you want to survey people's satisfaction with an airline. You don't want to have to, okay, I want you to imagine a numbered list of passengers on a certain airline in one day. How long would that list be? Really, really long, like Santa's list. It would make a sound as you rolled it out, like that. They roll up and stuff. Okay. Would it be easy to do a simple random sample? Okay, you'd be like, oh, I gotta go ask Fred Williams on flight number 715 how he likes his flight. And then I gotta go ask George Stevens on flight 1291 how he likes his flight. Does that make sense?
Yeah.
Okay, instead, what airlines will do is they'll say, okay, each flight is a cluster. They'll list out just the flights for the day, randomly choose a few flights and ask everyone on the plane. That's a cluster sample. It's kind of a convenient sample. It is. It's kind of a convenient sample. It's like geographically located next to each other. So this is my other favorite one. Picture Jake. Jake is working for the Giants and he wants to ask how people like the food. Okay, Jake's got a list of all the seats in the ballpark. Do you see how long it is? You know, super long list of seats. And he's got to go ask Mrs. Talbot and the ticket that she stole from his mom and that seat. And then he's got to go all the way up to the, bleachers and ask somebody up there. And then he's got to go ask somebody like, way behind the mitt. And Jake's just running his butt off. Okay, instead, what Jake could do is a cluster sample. He lists each of the sections of the baseball stadium, does a cluster sample of a couple of sections and goes and asks everybody in that section instead. Is it kind of a convenient sample? Yes. Okay, what your hope is that each one of those little sections is kind of like a mini population, diverse enough to reduce bias. Unfortunately for Jake, it's gonna be like, oh, well, everyone in the expensive seats probably likes the food more than everyone in the cheap seats because it's so expensive there. But he would have to write about that bias in his report. Okay. When you're working for marketing for the Giants, you know. Yeah, exactly. He's gonna write me someday, be like, Mr. Talbot, I just did a cluster sample. He's not. Anyway, okay. All right, so step one, separate population into clusters. So these clusters don't really have anything in common. They're just kind of conveniently located. Okay, so choose a simple random sample of cluster numbers. So that would be a whole flight or a whole section in the baseball stadium. Does that make sense? Your hope is that they're diverse when you get to them, but they're probably not. There's probably some bias. Okay, combine all individuals from the chosen clusters into one large sample. Okay, I need you guys to look at, when you're done with this, look at the next resource page, which says dog breeds listed by group. Okay, and this time you have to kind of pretend that at the dog show, they put all the herding dogs together. So this is going to be cluster one. Is the herding group. Cluster two is going to be the hound group. Cluster three is the non-sporting group, which is where I believe my dog is. Oh, lies. He's in the sporting group. I have this one. Dog number 42. I have two dog number 42s. Yeah. Oh, and I have a 52 also. I have two 42s and a 52. Why do you have three dogs, Mrs. Talbot? Well, that's because I had two dogs and then I met my husband and he had a dog and a cat. And then we moved in together and now we have the Humane Society at our home. So. Okay, now, let's see. Toby, how's that hair underneath that beanie? Are you sure?
Yeah.
Well, you see, our directions specifically say use the hat method. Now, these slips of paper are supposed to be identical. I'm doing my best. Well, yeah. Okay, now we are doing sample sizes of 15 dogs. Do you guys notice that the clusters are not all the same size? And you notice that, like, none of them are gonna give me 15 dogs. So the closest I think is just to select 2 clusters. Because that would give me close-ish to 15 dogs. It's not even that bad. Okay,
It doesn't sound that bad.
it's not. All right.
I mean, she said it looks good. How many?
2. We gotta mix between
All right.
cluster 1, what did you say?
Oh, 4.
4, that's our first cluster.
7.
7, nice. Thank you. Easy restaurant. Do you guys all understand how the half method works?
Yeah. Yeah. Pretty self-explanatory.
Yeah.
I think an example like how this.
Oh, it really solidified. I think it was necessary. Okay. I'm saying this again because I don't really know how this applies to a dog show unless they have different rooms of dogs and or something, and they're like all the herding dogs go in room 1. That's just what I don't know. But it's cool. It's cool. Okay. 2. Now I'm saying 2 clusters here, but that's just because I wanted my sample to be around 15 dogs. The number of clusters can change from whatever your project is. Okay, so how many dogs would that actually be? No, I'll count. 22. 38. That's a lot more than 15 dogs. But anyway, that'd have a lot more weights I would have to average, but it's okay. Do you have any questions about cluster sampling at this moment? Okay. Anyone still writing from the screen? Yes. Okay. Tell me when you're ready, honey. Okay, now we need to go back here and talk about what a systematic random sample is. This one we're not gonna actually carry out, we're just gonna say what it is, how to do it. Okay, so a sample chosen in which the first individual is chosen randomly, so they choose a random place to start, and then you choose every like 7th one, or every 10th one, or every 9th one. This is used on assembly lines a lot. So like if they want to measure something, how defective something is, they might take every 100th car off the assembly line, if that makes sense. Okay, so first step is always numbering. Next question I have is, which one of the resource pages is by breed? Is it the last one? No, it's the first one, huh? Yeah, it's the alphabetical one. Okay, so find the alphabetical one. Okay, in our describe how we would obtain it, we would say number of dogs from 1 to 118. They already did it for us, actually. We have a very nice sampling frame given to us by our friends at CPF. Okay, does this make sense? This bullet point and this. Okay, step 2. Choose a random individual to begin your sample. Do you guys want to do this with technology, hat, or table of random digits? You should always answer technology. You can make 118 slips of paper on your own time, but I'm thinking technology. Okay, so step 2. Okay, now I want to choose out of all the dogs. So what would the lowest number be? And the highest? And how many dogs do I want to choose? 1. I'm just choosing one random dog to start my sample. Okay, so you guys go ahead and figure out what dog is going to start your sample. Oh, I'm starting at dog 2. You're like at the end. So put whatever you got here. Okay, now we need to figure out how many dogs we need to choose, how many we need in between each one. And so we need to calculate Why did I write dogs in my notes thing? Back to dogs. How many dogs do I want total? And how many do I have total? Okay, so I'm gonna go 118 divided by 15 is 7.87, and I'm gonna round that to 8 every 8th dog. Okay, so we're not gonna spend all day on this, but it would be, the first dog in my sample would be 2, and then 10, and then 18, and if you're Nami and you started at the end of the list, then you have to wrap back around to dog 1. So, yeah. 115, and then 16, 17, 18, 1, 2, 3, 4, 5. Okay, last step. Any combination of the other 4 methods of sampling is called multi-stage sampling. So for example, say you're Jake and you're like, only want to ask a few people at the ballpark. Okay, so Jake has a list of all of the sections of the ballpark, right? Say he picks 3 of those sections. He's saying, I don't really want to ask everybody. So then he takes section, he takes section 216, and he's got another list of all the seats in section 216, and he does a simple random sample to select 10 of those seats. That would be a multi-stage sampling because he did a cluster sample to select a section, then he did a simple random sample inside the cluster to narrow it down further. Okay, another way would be like, let's say you're worried about defects in your calculators. You look at all of the different plants that produce these calculators. You do a cluster sample to pick a couple of plants, and then you do a systematic sample to say, okay, I'm going to choose 126 calculator that comes off the assembly line, and then I'm going to choose every 100th calculator after that to look at. That would be multi-stage because you did a cluster for location, and then you did systematic to get every 100th one that came off. Does that make sense?
Yeah.
Okay. So what do we have to write still? This last thing. Okay. You are not going to be able to do the 4.2a homework, but do you think you can finish the 4.1b homework now after this?
Yes.
Okay, so I'm just gonna check the 11 to 23 odd and 35 to 42 on Monday, because I didn't have it. I'm still working on catching up. Okay.
Yeah, that's what.